this video, we're going to talk about three types of reactions: acid-base, precipitation, and oxidation-reduction reactions. Let's start by talking about acid-base reactions. For AP Chemistry, we use the Bronsted-Lowry definition of an acid. A Bronsted-Lowry acid is any species that can donate a proton. And when we say proton, we're talking about a hydrogen ion, which is basically a proton. A Bronsted-Lowry base is any species that can accept a proton, a hydrogen ion, and such a species must have at least one lone pair of electrons in order to accept this proton. In an acid-base reaction, there's a transfer of the proton from the acid to the base. You can typically tell you're looking at an acid-base reaction by examining the chemical equation. We should see evidence that a proton or hydrogen has been transferred from one species to another. We'll talk more about acid-base reactions in the next video. A precipitation reaction is a reaction in which dissolved substances react to form one or more solid products or precipitates. These reactions are generally double displacement reactions. Many reactions of this type involve the exchange of ions between ionic compounds in aqueous solutions. A precipitate forms when the attractions between oppositely charged ions is greater than the forces of the attraction between the ions and the water molecules surrounding them. Generally, the positive and negative ions of two ionic compounds exchange places to form two new compounds. Here's another example of a precipitation reaction that is double displacement. We can see that the nitrate and iodine ions change places. Lead 2 iodide is insoluble in water and precipitates out. Potassium nitrate does not precipitate, it stays in solution. So here's a question: how do we know if a compound will precipitate out or if it'll stay in solution? Well, the answer is solubility rules. There are lots of solubility rules, and you can memorize them if you want to, but you don't have to do it for the AP exam. You do, however, need to remember this: all salts that contain the ions sodium, potassium, ammonium, or nitrate are soluble in water. That means they aren't going to form precipitates. They're going to be spectator ions in aqueous solution. So let's take a look at this equation here, where we have silver nitrate reacting with potassium dichromate to form silver dichromate and potassium nitrate. So say we do this reaction and we see a precipitate. We know that the precipitate must be silver dichromate, and that's because potassium nitrate is soluble in water and doesn't precipitate out because it has the nitrate ion. One sign that a precipitation reaction has occurred is that there is a production of a precipitate. When you're looking at a chemical equation, look for the telltale S symbol after one of the products. If your reaction's occurring in solution, that little s tells you that a solid has been produced and that there is a precipitate. The third type of chemical reaction is an oxidation-reduction reaction, also referred to as redox. Redox reactions involve the transfer of electrons between atoms, ions, or molecules that are involved in a chemical reaction. You're probably familiar with several redox reactions already. For example, the combustion of methane is a redox reaction. So is photosynthesis. So is the rusting of iron. During a redox reaction, one or more species undergoes oxidation. That means the loss of electrons. One or more species undergoes reduction. That means the gain of electrons. Oxidation can occur between metals and nonmetals, and it can also occur between nonmetals. One useful memory aid for remembering what happens during oxidation and reduction is Leo the lion says grr. Leo stands for lose electrons oxidation, and grr means gain electrons reduction. So how do we know if a reaction is a redox reaction? It's not too difficult if you have a situation like this one here. We have iron, which has no charge on it, forming iron 3 plus ions. Now, in order to figure this out, we have to recognize that the Fe2O3 on the right-hand side is an ionic compound, and we have to, in our mind, break it up into the iron and oxygen ions. Because iron is losing electrons, we say that it is oxidized. Lose electrons oxidation. We can also see that oxygen, which starts out being neutral, gains electrons to form the oxide ion, which has a 2- charge. Oxygen is reduced. Gain electrons reduction. But it's much more difficult to identify an oxidation-reduction reaction when you have a situation like this one, where there are no obvious charges, there are no obvious ions participating in the reaction here. In order to figure out if a redox reaction is happening, we need to use oxidation numbers. An oxidation number is the charge on an ion or the charge an atom in a covalent compound would have if it were an ionic compound. Oxidation numbers are written with the charge before the number instead of after, +1, +3, -1, etc. There's some oxidation rules that you should know, and these are going to help you determine what the oxidation numbers of the different atoms in your chemical equation are, and if a redox reaction is happening. Rule number 1, the oxidation state of any pure element is always going to be 0. We're talking about things like metals or about nonmetals that tend to exist in diatomic or polyatomic form, like molecular oxygen or molecular fluorine. Rule number 2, for monoatomic ions, the oxidation state of the ion is always the charge of the ion. So from this table, you can see that the zinc and iron ions have the oxidation states that match their charge. But in that diatomic mercury ion and the peroxide and superoxide ions, the oxidation states of the atoms in these compounds add up to form the charge on the ion. So for example, in peroxide, the diatomic oxygen ion has a charge of -2. However, each oxygen within it has an oxidation number of -1. And if you add these together, you get the total charge on the ion of -2. Rule number 3, when combined with other elements, alkali metals always have an oxidation number of +1, and alkaline earth metals always have an oxidation number of +2. Rule number 4, fluorine has an oxidation number of -1 in all compounds. Rule 5, hydrogen has an oxidation number of +1 in most compounds. The exception is when it is combined with metals, the oxidation number is -1. Rule 6, oxygen has an oxidation number of -2 in most compounds. The exceptions are peroxides, where oxygen has an oxidation number of -1, and superoxides, where oxygen has an oxidation number of -1/2. Rule number 7, other halogens like chlorine, bromine, and iodine have oxidation numbers of -1 in compounds unless they're combined with oxygen or fluorine. Rule number 8, the sum of the oxidation numbers for all atoms in a neutral compound is equal to 0, while the sum for all atoms in a polyatomic ion is equal to the charge of that ion. Remembering electronegativity can be important in helping us decide oxidation numbers. Since fluorine is the most electronegative element in a periodic table, anytime it's in a compound, it has an oxidation state of -1. Here's an example. We have OF2 oxygen difluoride. Fluorine's always going to have a -1 oxidation state. And so because our compound has to have a neutral charge, oxygen is going to have an oxidation state of +2. So this is one of those exceptions to the rule where oxygen does not have a -2 charge. Now, in order to determine whether you have a redox reaction, you need to assign oxidation numbers to the atoms in your reaction. If the oxidation numbers for one or more of the atoms changes during the reaction, you have a redox reaction. For example, in this reaction, iron goes from an oxidation state of 0 to +3. It loses electrons, so it's being oxidized. Oxygen goes from an oxidation state of 0 to -2. It has gained electrons, so it is being reduced. And we will do more of this in an upcoming lesson. Let's summarize. In a Bronsted-Lowry acid-base reaction, one species will donate a proton and another species will accept a proton. And when we say proton, we're talking about a hydrogen cation. Precipitation reactions tend to be double displacement reactions between ionic compounds, and they tend to produce a solid which precipitates out of solution. And oxidation-reduction reactions involve transfer of electrons between atoms, ions, or molecules in a chemical reaction. In order to determine if a redox reaction is happening, you have to assign oxidation numbers, and then see if the oxidation number for one particular element changes over the course of a reaction.